Thank you very much, Emma. Much appreciated. Thank you for your kind words of introduction as well. So a little bit more about me. As you know, my name's Neil. I live in South Manchester with my wife and two children. My technical background, I studied geography, then joined an engineering consultancy doing flood risk and water quality modelling. I've worked around the UK and overseas, including spending 2 years living and working in the Republic of Ireland, which is where I met my wife. I got involved in digital approaches to the water market through applying GIS approaches to solve client problems. So with two colleagues, I led development of a GIS-based SUDS opportunity mapping capability, then a linear infrastructure, so water supply pipe and electricity transmission line route finding approach. I also helped lead an initiative digitizing how environmental assessments could be undertaken, looking at digital tools as well as the behaviors and training needed to help people adopt the new ways of working that we identified and delivered. So I'm currently working for Binnies, and I'm going to talk today specifically about doing digital in the water sector and some of the experience that Binnies has in that area. So Binnies is an international consultancy with offices around the world, mainly in the UK and Asia though. We're part of the wider RSK group of company, which gives us access to an even wider range of expertise and experience in offering sustainable solutions to the issues facing the world. Binnies is predominantly focused on the water and environment sectors, offering services to do with flood risk, drainage and water supply in the water sector, as well as a comprehensive range of environmental services, which I know slightly less about. I sit in our digital products and services team, which serves both the water and environment part of the business. In the webinar today, I'm going to be looking at some case studies of where we've applied digital solutions to different issues facing different parts of the water sector. And then I'm going to summarize at the end by considering the pitfalls to consider and opportunities associated with the digital approaches. So the first of our case studies. This is for a client called Thames Water. You might know them. They have about 10 million water customers across London and the Thames Valley and a massive water supply infrastructure to manage. They have a target of reducing reportable leakage by 20% between 2020 and 2025, meaning that leakage detection and repair is a major focus for the company. But it's a very labour intensive activity that takes a lot of time and effort to identify each leak. The brief of the project was to target leakage in a defined region due to increasing challenges around the identification, verification and successful repair of the leaks. So what did we do? We worked in partnership with an organisation called Fidotech to look at artificial intelligence leak detection. The map that you can see on the screen is leakage data from a study that has been deliberately plotted over the Lake District, so to protect the anonymity of the pipelines involved. But the approach involved leakage detection efficiency improvements. So applying the artificial intelligence, we were able to identify leaks with a 92% accuracy and with a 20% leakage detection efficiency. The greater accuracy was achieved by using acoustic monitoring, and it was far more efficient than sending people out on site. We were able to use the monitors that were installed instead temporarily. The study informed repair prioritisation through its leak sizing capability, so we were able to say whether the leak was likely to be significant or not. And it took advantage of a fully automated process. So in the case of this study, 35,000 sound files were analysed in about 2.5 hours. So as with lots of digital products and approaches, the actual application can be really, really quick, but there's lots of setup that's required before that happens. So the project lasted slightly more than 2.5 hours in total. In this case, about 77 leaks were identified, which was a really good result, and the client was really happy with it. So this provided standardized daily outputs. So every day we could look and we could see were there any new leaks, were the leaks getting worse, did they seem to be reducing in their size or not? And this delivered operational leakage improvements by identifying leaks and aiding the repair prioritisation. So the business was able to identify which leaks to go and address first because they were the largest or potentially the most significant in terms of their potential impact. A key lesson from this implementation was that the business implementation revolved around people, not necessarily technology implementation. So just having the artificial intelligence and the technology available didn't solve the problem. People actually had to engage with it and use it to deliver the outcomes to the business that the business wanted to see. And that's something that we'll pick up in the summary later on. So the next case study that we're going to look at is for a confidential organisation. that has an extensive portfolio of dam assets across England. So in this case, the brief was to establish the long-term baseline rhythm of a dam asset to understand when it might be starting to act abnormally, so they could investigate and undertake any identified maintenance or works that were identified as being required to ensure that the dam continued to operate in a safe and as expected way. So our solution was to apply IDMS, which is our intelligent dam monitoring system. IDMS utilizes data from Resitech, which is a satellite data company. And this identifies potential changes in elevation of the dam face itself, i.e. movement. It looks at soil moisture and vegetation as well on a seasonal basis, as dams often have a seasonal behavior. And you need that long-term approach to understand the seasonal variation that you'd expect to see year on year before you overreact because it's starting to swell slightly or change slightly in response to higher temperatures, more rainfall, etc. So IDMS uses historic data to establish a baseline rhythm for the dam characteristics and then compares current values to these baseline values to highlight anomalies or areas of concern. And it does that by flagging up, you can see on the picture there's all those polygons. So you can see in the graph how the values have changed over time. You can see that there'd be a seasonal response to that if it was a slightly longer time period. And then the polygons that you can see, the hexagons are colored in to show whether something is within tolerance, whether there's more monitoring that's required, or whether immediate action is required and you need to escalate that and address it. So a key consideration for clients is reliability of the data. So we undertake an exercise to validate the satellite data against ground survey data to prove the reliability of the satellite-based information and to improve its robustness and the level of trust in it. We also bring in data from SCADA telemetry systems to consider variables like groundwater levels as well. So we can add that context and client data sets to expand the coverage of factors that are considered through the system. We're currently applying this on behalf of several dam operators in the UK. And as an example, when we looked at data for a UK dam that had experienced a significant spillway failure, the data clearly showed a change in elevation values in the run-up to the dam failing. So if the system would have been in place, then the organisation responsible for the dam would have been able to see that there were changes taking place and that they might need to go out and inspect it or put some maintenance in place. So the next two case studies are going to be looking at Helix, which is our operational intelligence platform being applied to two clients. So this is effectively digital twinning or digital shadowing because we're not feeding information back into the system to influence control at the moment. So our third case study is for a confidential UK water company. So the brief from them was to make better use of their data and analytical services to enable the successful delivery of their client of the dynamic maintenance strategies that they have for AMP7 and beyond. So their strategy focused on sustainably maintaining service level requirements through proactive condition and performance management of key assets and processes. It required a platform that could integrate multiple sources of static and dynamic information. So that's things like O&M manuals, as well as SAP data and SCADA data, combined with predictive analytical modeling to give users intuitive data-driven insight. So rather than relying on experience and feel, and I think this is going to happen, actually providing data to make decisions and to inform actions. So they selected an asset to apply this to, and the asset they chose was a complex pumping station. It's very expensive to operate and maintain. It's their most expensive pumping station asset in their portfolio. One of the issues that they had was the difficulty in triaging alarms. So in one day in November last year, they had 17,000 alarms in one day. So that's things to do with asset health, that's things to do with thresholds being passed, and trying to manage that and gain insight into what's important and what's not is a real challenge. The maintenance resources required at the asset are complex as well. It requires multiple maintainers to work in combined spaces. So health and safety is a significant issue for them, as well as the availability of resources to get the required number of people to work safely. So anything that they can do to identify improvements to the efficiency of the maintenance makes a big difference to how they run as a business and how that asset is maintained and operated. It also has a significant impact on a downstream wastewater treatment works that it pumps to as well. So these are all things that made it important and a target for their consideration. So this is a interactive Matterport scan, which was captured at the asset and which has subsequently been imported into the Helix platform. So this allows users to navigate and familiarize themselves with the site before attending, which has health and safety improvements, and also provides an interface to view real-time SCADA data, which the platform also connects to and hosts. So at the moment, Helix automatically consumes over 9,500 data points every 15 minutes, which is quite a lot of data to try and get your head around if you're just trying to do it yourself manually. To date, Helix has proactively notified the client of over 250 asset anomalies that otherwise might have been hidden in that really big data. So it's trying to surface that insight and help make good decisions. So this is a time series plot of some of the data. And what this is showing is on the top graph, you can see the expected pump well levels, which are the black lines. So that's from a model that the analytics team have built, and the observed pump well levels, which are the blue line. And in this, you can see the extended levels indicating a blockage, which could have been removed much earlier to allow the well levels to drop sooner. So that's an example of where we can apply data analytics to learn normal behavior and then start to flag and issue alerts when that normal behavior isn't met. The solution has contributed to over 30% reduction in reactive maintenance by proactively notifying critical asset anomalies, which is a really significant factor in terms of the operational cost and the operational reliability and risk associated with the asset. So our fourth and final case study is for another confidential UK water company. So in this case, the brief was from the client's capital delivery and design team, who had a desire to make better use of their data and analytics to support capital investment decision-making and support optimization of the CapEx and OpEx balance. Their asset management, capital delivery and design engineers and operations team needed indisputable evidential measures of operational process risk in order to inform the management of the full asset lifecycle. For these objectives to become a reality, the client required a platform that could integrate multiple sources of static and dynamic information combined with predictive analytical modeling to give users intuitive data-driven insight. So to do this, we ran a series of workshops. We spoke to the business, we spoke to the asset operators about the asset, we spoke to the asset operators about themselves, and then we understood the data availability and the types of monitoring that were going to be available. So this was applied to a complex wastewater treatment work asset, where there were significant challenges on a variety of elements of the process, including managing the mixed liquors. So better operation of the inlet, blowers and screen backwash were also desired because they identified that there were efficiencies that they could probably make there. They also wanted to manage their energy better, so the blowers are very heavily energy intensive, and to improve the overall asset efficiency. And they wanted data to provide near real-time evidence for capital investment. So not just looking at the operation and management of the site, but also getting feedback and using that to influence design of features going forward. So the solutions, we incorporated SCADA and other data into Helix. This improved data visibility and meant that they were able to see data in a way that they couldn't through their existing SCADA interface and dashboard. Provided data trending, enabling us to identify the impact that a change operation could have on process efficiency. Incorporated process-related calculations to make those visible more widely outside the process team. Incorporate environmental forecasting to improve the accuracy of that, and also how specific it was to the asset rather than the wider regional forecast that they were currently utilising. To provide alerts on operations, which were able to bring in factors from the SCADA telemetry system, and also provide performance comparisons between design and operation. So to see how the asset is actually operating compared to its design case, rather than just being able to see how it's operating at the time. There's potential for linkage into other systems such as SAP, which contains information on maintenance regimes and material usage, and also energy management systems as well. And it can also support other internal initiatives that are trying to deliver digital outcomes. So on the next slide, you can see a case study. So in this case, on the 23rd of February last year, the Amber Alarm threshold for a CBM score was breached, and this prompted them to pay attention and adopt a watching brief. The following day, the Red Alarm threshold for the score was exceeded, and the asset health risk score was at a sustained high level. So this prompted an operational response. And the operational intervention occurred before the catastrophic pump failure would have happened, and that avoided service failure of that feature of the asset. So again, that's applying the models, looking at thresholds, and then telling people to pay more attention and then go out and do something before it's too late and the asset's actually failed. So that completes the examples of applying digital solutions to water issues. So I'm going to move on to some of the high-level considerations that those flag up in terms of the pitfalls and the potential benefits that digital solutions can achieve. So some of the pitfalls. The biggest thing, I don't know how many people on the call are modelers, but you'll know how important data quality is. So the quality and comprehensiveness of available data can really vary significantly. If data is poor, then solutions that are developed will also be poor because you're giving it uncertain information and it's using that to base its modeled outcomes on. So sometimes this means that significant amounts of time will need to be spent understanding and curating the data, improving its quality before it can be used. Often the process of trying to apply digital approaches will highlight issues like this that were previously unrecognized or ignored. The quality of the data hasn't changed, but people's understanding of how good it is might be different because now you're actually going to try and use it in a way that might be different to normal, and that's flagged issues that previously were unknown about it. Data availability or access can also be a problem. Once the type of data available has been identified, it's been quality controlled, its quality has been improved, accessing or connecting to it, particularly if you want to do something in real time, can be a real challenge, depending on clients' IT systems, security protocols or requirements, experience of sharing data and perception of the risk of sharing data as well. Within the water sector, sharing data has often been quite difficult, with different organisations being unwilling or unable to share data widely. And when you're trying to do something digital with particularly real-time data, that becomes an even more significant hurdle to overcome. And the advantages of sharing data are significant. The next potential pitfall is with engagement. So engagement by staff that will use the digital solution is really important. The right people need to be engaged to inform the production of helpful digital solutions, and end users need to be engaged so the solution actually gets used and implemented. When you're pulling something together, you need to be able to answer the so what question. I've got this new technology, so what does it mean to me? Why should I use it? If you can't engage with end users, the chances are you'll achieve an outcome or a tool or an app or something that looks great, but doesn't actually get used by anybody. And you've wasted a whole load of time and effort in producing that, and it's not giving value to the business. So you need to make sure that staff are engaged and that they understand what you're doing, why you're doing it, and the advantage that it's going to give to them. A lot of people can be intimidated by digital. They think you're taking a job, or you're removing tasks from them, and what are they going to do instead? So engaging with people to help them to understand that you're trying to help them and give them tools that will reduce their stress and their pressure, and help them to make better decisions is really important to getting them on board and getting them engaged. So another element of this is to do with training. So staff will need training in how to use the solution so they have confidence in the solution and understand its strengths and its weaknesses. This can be through reading a user manual or going through a formal training program. But for lots of people, it'll just be a case of getting access to something and trying it, clicking on some buttons, looking at what the outputs are, having a play with what they can do with them themselves. And as much as anything else, it's about adopting a different mindset rather than reading books and blogs on the issues and coming up with a theoretical knowledge. People and businesses are still trying to work out what digital actually means to them individually and as an organization, how they can use it effectively, and what benefits it'll bring them. And that needs engagement and the opportunity to experiment. And although there's technical learning and technical understanding, which is important in that, it's also about culture and behaviors. And that's a longer term change that needs to happen. That's not something that you can change quickly. The next thing is trying to ensure a joined up approach where possible. So in the push to engage with the digital agenda, it's possible to have multiple initiatives which may not be integrated together within the same organization. It's entirely possible to have teams unintentionally trying to achieve very similar and overlapping objectives within an organization, but not really talking to each other and therefore doing things in parallel. This also relates to having a strategy. It's not unusual for teams to get all excited about digital and be, oh, I need an app, I need a tool, I need something digital to solve this problem that I've got. It's not always the case that that's what's necessary. Frequently in this scenario, the team first needs to understand and define the processes it follows. This can often result in improved performance just through standardizing approaches to a problem. And it's a necessary first step in developing the understanding required to create an app or a tool in any case. Not doing this can result in a load of wasted time and effort. So making sure that you've got a strategy and you're doing things in a joined up way, that you understand the problem, that can really result in a lot of improved efficiency and making sure that what's built is actually helpful and delivers a required outcome. So the last thing in terms of pitfalls is people. And by that, I mean resource availability. This is an exciting, expanding field, and the number of people with the relevant skill sets currently doesn't match demand for services. Loads of organizations have got digital things that they want to do, but the number of people that think in a way that enables that, or have experience of trying to do things in a different way, or even have the practical coding skills or data management skills or data analytics skills to make those dreams happen, is lower than it needs to be. And that's an issue. It's not that difficult to overcome. Training can help, as we mentioned before, in terms of technical ability, so learning coding languages, learning how to manage data better, but also it's the approach and the mindset that's also really important to think about and to engage with and to try and change, particularly where you're trying to do things at an enterprise level and you need to get a whole big team of people on board. There'll be a whole range of different attitudes and experience in that team, and changing people perception and willingness to engage is a really difficult and issue that takes a long time to resolve. However, having got all the pitfalls out of the way, we can now finally look at the benefits, and there's loads of benefits. I can't list them all, but we'll go through some of them. So the first thing, from business's perspective, evidence of operational risk. So using data to provide evidence that an asset may not currently be operating efficiently or might not soon be operating efficiently is really important. A particular advantage of digital approaches is the ability to scale risk assessments at pace across an organization. So while each asset needs to be considered on its own merits, some standardized measures of asset health and risk can helpfully be applied consistently across assets of the same type. So assets might have particular issues and they need to be investigated on a case-by-case basis. But where you've got common data available for the same kind of asset in lots of different locations, where that's been automated or where you've got analytics applied to it, that means you can scale those analytics quite widely, quite quickly. And that produces some really helpful benefits. We'll touch more on those now. Operation of the asset is optimized or uncovers opportunities for further optimization. Having access to asset data means you can investigate and prove whether the asset operation is optimized or uncover new opportunities to improve operation. This is about business assurance. Is the asset being operated effectively, or can its operation be improved? Again, common approaches can be widely applied across an asset base, providing a consistent understanding of asset performance. And that's often something that's missing. There might be different people trying to assess different assets in slightly different ways, producing reports in slightly different formats. Where you've got a more digital approach, you can apply consistent assessments to a wide base of assets. And then that standardizes the responses, which means that you can then have a more standard and common understanding of assets across a whole organization. And that helps to improve investment decision-making and other things as well. Again, we'll touch on those in a second. So the third thing is verifying factors affecting asset performance. So data analytics can demonstrate relationships or lack of relationships, and proving a negative, it's equally as important, between data associated with the asset, providing evidence to underpin asset operation. This understanding can also be used to influence design and provide evidence to input into capital investment business cases. So where you've got an experienced operator or maintainer, they might understand the factors that are affecting the asset performance. If they're on holiday, then that information and that understanding isn't available. Where you've got a digital approach that captures some of that insight and understanding, that best practice and that understanding can then be shared with their peers, with managers, and it widens the resilience of the organization. Proving relationships between different factors that influence asset performance and having hard data to back that up is really helpful, because it can then be applied to other situations where you're just relying on an operator or maintainer to manage the asset performance. That understanding is often quite opaque. It's not made available throughout the organization. It makes it really difficult to learn from that and use that understanding to influence design to come up with long-term sustainable solutions to common problems. So we can also identify previously unknown factors affecting asset performance. As well as proving known relationships, digital approaches utilizing big data can also uncover previously unknown relationships, providing insight and opportunities to do things differently, whether that be the specification, design, or operation of assets. Being able to identify potential future improvements to design, not just operation, could save the industry significant amounts of money in the future. As people, we're naturally comfortable with what we already know, but when we've got big data sets to look at and we can ask questions across that whole data set, that can help to independently identify relationships that we might not be aware of, which gives us new avenues to investigate to improve the operation and design of assets, and helps us to do our jobs better as well. So utilizing big data has lots of advantages in that way. Making existing and new data available to people in more useful ways can provide insight and value and resilience. Sometimes with digital approaches, you don't have the data you want, and sometimes you have way too much data and it can be difficult to understand what's important. The best digital approaches provide users with the data they need in a way they can use it. Digital can be complicated, but the best digital is presented in a simple way that is easily understood by people and avoids confusion and provides insight. Taking the complex and making it simple is part of what the skill set that digital approaches really need. Digital can provide the best view of data from every expert's perspective. We've talked a little bit before about resilience and how if one person is away, often without a digital approach, that information or that perspective can be lost. Where you've got dashboards or common approaches, that expert's data view, what they think is important, can be shared more widely. And if they're not there, it doesn't matter as much. Other people can still see the same information. Sorry. So that helps to provide resilience if that person's on leave or they're ill. Other people can pick that up. It also provides training to other people. They can see what's important to the lead operator. They can use that information themselves then to operate the asset better. Hang a second, I'm going to cough again. So 2 more to go. Digital can help people and businesses to be more knowledgeable and resilient, which is what I've just been talking about. Having good data displayed well informs decision-making and provides institutional resiliency. If the expert has established a digital approach that incorporates their understanding, particularly if the approach is cloud-based, but that person is subsequently unavailable through holiday or illness, as I mentioned before, that person's digital approaches can be shared with others, increasing those other people's knowledge and providing resilience in the absence of the expert. And the last one, and perhaps the most important one, opportunities for personal growth. Digital is really interesting and exciting. Doing things digitally often involves creating new ways of doing things and gaining new insights into long-standing approaches or problems. It stops our jobs from getting tedious and repetitive and offers loads of opportunities for growth and development. There's nothing more exciting than solving a problem that someone's been struggling with for ages and being able to do things in a new way as a result of adopting a digital approach. So that is a couple of case studies that give some examples of what applying digital can look like, and then some higher level summaries of the pitfalls and practical benefits of doing so. So hopefully there's a few questions. I'm going to have a drink and then I'll answer any questions that anyone's got.
Thanks very much for that, Neil. That was a great presentation, very much appreciated. And yeah, that was you know, lots of good tips there on pitfalls and benefits, etc. as well, which is fantastic. In terms of the questions that have been asked, I've only got one in the chat at the moment. There's been There's been two that have already been answered, but I think they were more general. So Mariana's got a question. So thank you for the presentation. You mentioned the important issue of data reliability and trust in your second case study. Furthermore, you mentioned data availability and access. What solutions do you currently offer to tackle these issues? On the same note, how much have you heard about combining blockchain technology in this area? What's your personal opinion on this?
Okay, I'm going to mute myself every now and again while I cough. Sorry.
No, don't worry, Neil. Take your time.
No, I promise that's not just to buy myself some thinking time as well. Okay, so in terms, I'll try and address them each in turn. So data reliability is really important, and not just reliability, but quality as well. Any modelers that are on the call will be well used to the pain of getting data and then trying to have to work out how good is it? Can I rely on it? Is it representative of what it's supposed to be representing? Is the data actually that I've got available actually the right data that I need to use, or am I going to have to use it as a proxy or interpolate it in somehow? So I think as an industry, there's good experience of data reliability and quality and the issues associated with that. I don't think that's still resolved. I think even within modeling studies, there's a danger of believing that the model is a deterministic answer. So the model's told me this, it must be true. Establishing trust is really important in that. And in a wider digital context, the lessons that the modeling community, I think, still struggles with in terms of helping people to understand interpretation of the models is still relevant to digital. Digital is great, but it's not perfect. And there are constraints and there are limitations with digital approaches as there are with anything else. So I think it's really important to be open about what the benefits and what the strengths of different approaches are, but also making sure that end users understand how to interpret the data and don't just treat it as a black box. So if they treat it as a black box, then that's when it can start being used in inappropriate or unfortunate ways. So in terms of solutions to data availability and access, the two clients that we're dealing with at the moment, we're accessing their SCADA systems. I'm not going to get too technical on it, partly because I'm not that technical myself and I'll get it wrong. But fundamentally, there are different ways that you can send and receive the data. So some organizations prefer to push the data out. So they'll effectively issue it to a specific location, which is, in this case, the Helix platform. And the Helix platform will then accept that data. And some organizations prefer that because they're in control of sending it out to a specific location. So they feel that there are security benefits in that. Otherwise, you can pull the data. So effectively, Helix will send out a request to an API and get that API to issue the data. They're the two main approaches of getting hold of the data. And each of the two clients that we're dealing with has taken an opposing view as to what they feel most comfortable with. And I think the flexibility to meet with clients where they're at on their data journey is really important. As an industry, we're still learning what this looks like. Obviously, there are issues to do with data security and availability. Data sizes are really important as well. Some of these data sets are massive, and over time you build up gigabytes and gigabytes of data. So I think it's about working through the issues as organizations and trying to come up with an approach that meets the requirements of both parties. And that'll look different for each organization. I don't think there's a one-size-fits-all solution to that. In terms of blockchain technology, yeah, that's well out of my skill set and experience, I'm afraid. I know what it is, but I don't know that I haven't heard of any applications of blockchain at the moment. If anyone else is on the call and they have got experience of it, then please lob something in the chat and contribute to the discussion. I think blockchain is great for security and tracking change. I don't think with telemetry data, that's necessarily a huge application of it, but someone might have a different opinion. That's just off the top of my head. Does that answer all the question? I think I covered
Yeah,
all of
yeah, I
it.
think you've covered all the question there, Neil. So thank you very much for that. We've got 2 more questions. So they're both anonymous. Do you see Fido being used more across the UK? How accurate do you think it currently is?
I can
First.
confidently answer yes, because I know that there are other projects that are about to happen where Fido tech is being used. In terms of its accuracy, I haven't been directly involved in the project, so I can't give any more statistics than the ones that I presented earlier on. My understanding is that it is accurate and does offer significant benefits over manual leakage identification. And also because of the way it's able to work with different types of pipe material, that gives it quite a significant advantage over some other approaches that only work with specific material types or can't work with plastics. And I think the ability to size the potential leak is also significant because that gives you another dimension of data to start to prioritize response. So I think that's all I can give on that, I'm afraid.
Excellent. Okay, I think that one's done, which is great. The next one is, what other applications can Helix be used for other than flow meters or pumps? E.g., can it be used for tank levels?
Yeah, anything that has got telemetry data associated with it. So we've got wet well level, we've got screen status, we've got pumps on and off, we've got ammonia, phosphate levels, iron, turbidity. You can do various calculations based on different parameter types. You can look at asset health. You can look at intervals between maintenance. Anything that's got a telemetry data stream can be absorbed. So you saw it with the Matterport image, for example. So there's a Matterport viewer built in. There's BIM models incorporated in. You can look at site plans. You can incorporate SAP report data as well. So assign maintenance, overdue maintenance to assets. It'll suck in any data you like, basically, as long as you can serve it up to the platform.
Excellent. I think that's all the questions done for now. Just a comment from Mariana. Thanks, Neil, for answering that question. Mariana would love to hear from anyone else with some blockchain experience as well, like Neil said. So feel free to reach out through LinkedIn. So that's great. I think that covers all the questions for now. Oh, just one more has just come in, so could take that one. I think accuracy of data at the source and calibration of flows, mag flow meters, and then maintenance is important. Cumulative errors can make leakage look wrong. I think that's just a comment, really.
Yeah, and I think an observation on that is that using the data in a different way through Helix has flagged issues with data quality and interpretation with some clients as well. So I think particularly in terms of spill frequencies and bathing water quality, I think there's lots of open data requests from organizations like Surfers for Sewage, or Surfers Against Sewage, sorry, where they can request event duration monitoring records and look at spill frequencies and stuff like that. And those data requests and looking at data through platforms like Helix are starting to flag up to water companies that some of their data isn't perhaps as representative as it could be, and that the interpretation of that data and what it actually means is really important. So yeah, cumulative errors and issues with data quality and interpretation are really important, whether it's in clean water supply, whether it's in wastewater, whether it's in flood risk modeling and mapping, all of those kinds of things. There are common themes throughout different applications and different disciplines.
Excellent. Okay, I think that's it for the questions. I think we had one on whether this will be available to view afterwards as well. So I think, Neil, we had a chat yesterday, so you were okay with this being uploaded to YouTube. So I take it Michaela is as well. And then So likely this will get uploaded. And I think that covers all the questions for now. So just like to wrap things up by saying thank you very much, Neil. It's very, very much appreciated. It was an excellent presentation and discussion on digital waters. And thank you again for everyone that's tuned in to join. And look forward to our next session. And thanks to Michaela and the your branch with TAC as well for organising this to begin with.
Well, thank you, Emma, and yeah, thank you, Neil. It's been a pleasure.
Thank you very much.